WPI-ICReDD, Institute for Chemical Reaction Design and Discovery, Hokkaido University. The theme of WPI-ICReDD is in-depth understanding and efficient development of chemical reactions.
Our goal is to revolutionize chemical reaction design and discovery by integrating computational, information, and experimental sciences. The Institute develops and utilizes computational techniques for predicting chemical reactions through quantum chemical calculations. This has enabled us to achieve computation-driven chemical reaction discovery, in which chemical reactions are first designed by computers and then verified experimentally. Now, by also incorporating informatics techniques, this approach can be applied to complex catalytic reactions. We are also taking on the challenge of creating chemical knowledge by building a database of predicted chemical reactions. Using a variety of computational and informatics tools, we are tackling more complex problems to understand and design solid-state reactions and polymer materials, and to understand and exploit hydrogel-activated reprogramming of cancer cells.
Our group is mainly exploring new reactions and new materials using automated synthetic robots. Automatic synthetic robots can perform experiments with high speed and high accuracy. Thus, they have a high synergy with chemoinformatics and theoretical chemistry analysis. We are currently working on the development of new reactions and the prediction of the physical properties of unknown chemicals by taking advantage of these features.
My research field is chemoinformatics, or application of informatics methods to solve chemical problems. Specifically, I focus on development of machine learning models for the design of new molecules and reactions with desired properties. Machine learning lets computers learn from existing experimental and computational data on how the properties of molecules are connected to their structures, and then predict these properties for new, non-existent molecules without performing costly experiments and calculations. I study efficient and meaningful ways of encoding chemical structures so that the algorithm may extract the most relevant information from the data.
The combination of metal ions and organic molecules can create and offer novel photophysical and photochemical properties. We can achieve functional materials based on the development of new metal complexes. For example, recently we designed a luminescent lanthanide complex which can emit red light. We applied this complex to tumor diagnosis. We think this is the first time that using luminescent lanthanide complex for understanding the conditions of tumors.
My research focuses on the use of computer tools to resolve chemistry-related problems in collaboration with the researchers of computational chemistry and experimentalists. So especially I'm working on the prediction of physico-chemical properties by machine learning derived from experiments. I also work on the representation of data sets which can contain up to millions of compounds, and also on the development of tools to store and use the chemistry-related data in a meaningful and understandable way for researchers coming from any research field.
The ICReDD building, completed in 2023, has research offices and research facilities on the same floor.
In these spaces, researchers from the field of experimental chemistry, computational chemistry, and information science work under one roof, an essential condition as a WPI Research Center without a barrier to collaboration. In addition, a full-time fusion research coordinator is assigned to promote fusion research from the bottom up, as well as facilitates the flagship project that serve as the core research in ICReDD.
Technical assistants are assigned to each lab to carry out experiments and collect experimental data, supporting researchers.
Here at ICReDD, we do research by combining 3 different fields: computational chemistry, information chemistry, and experimental chemistry, in order to discover novel organic chemical reactions. We conduct our own calculations, validate the results through experiments, and thereby contribute to demonstrating the accuracy of the calculations.
Professor Benjamin List, the 2021 Nobel laureate in chemistry, is also participating in WPI-ICReDD as a principal investigator.
I'm really fascinated with catalysis. It's for me the most fascinating science in the world, because on the one hand, catalysts are as close to magic as we can ever come. A single molecule of a catalyst in principle can create an infinite number of new molecules that are useful for our life. And on the other hand, that's the special thing about catalysis, it's also a technology. I think ICReDD promises really to deliver a revolution in this field, and I really want to be part of that revolution. And ultimately, who knows, maybe one of these people here will end up in Stockholm. I wouldn't be so surprised, you know.